A stand-up paddleboarder needs to paddle north across a 120-meter wide harbor. The tide is going out, creating a tidal current that flows to the west at 1.5 meters per second. The paddleboarder can paddle with a speed of 3 meters per second. In which direction should she paddle in order to travel straight across the harbor? How long will it take her to cross? So we can start by drawing the harbor, which we know is 120 meters wide. And the current travels west at 1.5 meters per second. So we want to travel directly north in this direction. So we need to add a vector to this 1.5 meters per second that will give us a sum of this vector here, which we'll label x. So the paddleboarder can paddle at 3 meters per second, which we can use as the hypotenuse of this triangle. Now if we want to find theta, the angle at which the paddleboarder is paddling, we can solve for that using inverse cosine of the adjacent over the hypotenuse. So 1.5 over 3. So inverse cosine of 1/2 is 60 degrees, and the paddleboarder is paddling 60 degrees north of east. Now we want to find x, or the value of x, the magnitude of the vector, which we can do by using the Pythagorean theorem. So 1.5 squared equals x, plus x squared is equal to 3 squared. So this can be rearranged as 3 squared minus 1.5 squared is equal to x, and we can put this under the square root. So x will give us 2.60 meters per second. Now that we know the value of x, we want to find how long it takes us to travel across the entire harbor. So we can use the equation v equals d over t. The velocity is equal to the displacement over time. So we have our velocity of 2.6 meters per second and our displacement of 120 meters, the distance that we want to travel. And that is all over time, so we can rearrange this to get t equals 120 over 2.6, which gives us a time of 46.2 seconds.